Assalamualaikum. My name is Ismail Bisa. As a representative of Group Expert 3, today I would like to explain about standard penetration test, commonly known as STP. So, what is an STP? It is an in-situ field test conducted within a borehole during site investigation. Its primary purpose is to measure soil resistance, which allows us to determine the strength and consistency of the subsurface. This test is vital for geotechnical engineering because it helps us determine soil density for safe foundation designs. By dropping a standard hammer from a fixed height, we record the number of blows. This is what we call the SPT N value. Essentially, the N value tells us if we are dealing with loose or dense sand or soft versus stiff clay. To perform this test, we use a specific set of tools, a borehole drilling rig to reach the required depth, drilling rods connected to a spill barrel sampler, which is a thick hollow tube with an outer diameter of 50 mm, a 63.5 kg standard hammer, an anvil and guide system to ensure the hammer falls exactly 0.76 meters or 760 mm, and finally a measuring tape to track penetration. The procedure is precise. We drive the sampler into the soil in 3 successive increments of 150 mm each, totaling 450 mm. The first 150 mm is called the sitting drive and is ignored in the final count. The N value is calculated by summing the blows required for the final 300 mm of penetration. If we hit 50 blows before reaching the depth, or if we encounter rock, the test is terminated. We also calculate the recovery ratio, which is the length of the actual soil sample, obtained divided by the sample's advanced length, expressed as percentage. The N value is a powerful proxy. It allows us to estimate unit weight, relative density, the internal friction angle, and undrained compressive strength. As you can see in the table from the Public Works Department, the N value of less than 4 indicates very loose soil, while anything above 50 is very dense. We also apply corrections such as a Terzaghi correction for fine saturated sands where N is greater than 15, or correction for energy efficiency to reach a reference of 60%, known as N60. Like any test, the SPT has its pros and cons. On the positive sides, it is simple, versatile, and cost-effective. It also provides a physical, albeit distributed sample for visual classification in the lab. However, there are limitations. The samples are too distant for advanced testing. The result can be inconsistent due to variation in hammer energy or operator techniques. Furthermore, it offers limited accuracy in soft clays and only provides point data rather than a continuous profile. In conclusion, the SPT remains a foundational economical tool for quick soil assessment. While it is widely used, we must remember that the results are sensitive to energy variability and soil conditions. Therefore, for a truly accurate site investigation, SPT results should be corrected to N60 and complemented with other geotechnical tests. That's all from me. Thank you.